Dear student, today I will discuss about the periodic properties. Periodic properties. What is periodic properties? The properties which directly or indirectly related to the electronic configuration of atom, and this property shows a regular gradation along the period or group is called periodic properties. That means, look at this point, regular gradation along the period or group means whether it decreases or increases. Suppose these are your periods and these are your groups. Suppose I want to move from left to right of a period, this period, there is a decrease or increase of the properties along the periods. Similarly, if I will move from top to bottom of a group, then the periodic property whether goes on increases or decreases in a regular manner. That is called regular gradation along the period or group. These properties are generally called periodic properties, and the periodic property most related to the electronic configuration of the atom. Accordingly, the electronic configuration of atom, the periodic property goes on decreases or increases. There are different types of periodic properties. There are different types of periodic property. There are different type of periodic properties. There are different types of periodic properties such as number one is your atomic radii, the plural form of radius. The plural form of radius is called radii. This is your singular, and the plural form of radius is your radii. That is your plural form. Second is your ionic radii. Next is your ionization energy. Next is your electron affinity. Next is your electron negativity. Next is your density. Next is your oxidation state and valency. Next is your metallic and non-metallic character. Metallic and non-metallic character. These are the periodic properties, and this property changes with respect to the periods and groups, and also depends upon the electronic configuration of the atom. At first I will discuss about the atomic radii. What is atomic radii? First is your atomic radii. What is the meaning of atomic radii? Suppose we take an atom sodium. If I will do the electronic configuration of the sodium according to the cell, then this is your said to be K cell, this is your said to be L cell, this is your said to be N cell. Here 2 electron present, here 8 electron present, here 1 electron present. This is your said to be your nucleus. This is your said to be nucleus. This is the center. And here valence electron is present. Then there is a distance between the center of the nucleus and the valence electron. This distance is called atomic radii. The distance between the center of the nucleus and the valence of the electron is called atomic radii. This is your called atomic radii. So we can write the distance between the center of nucleus and the valency electron. The distance between the center of the nucleus and the valency electron of an atom is called what? Of an atom is called atomic radii. Is called atomic radii. This distance can be measured by the help of some units. That is your centimeter, angstrom. Next is your micrometer, like this. So we can write second point. The atomic radii can be measured by centimeter, angstrom, nanometer, etc. Like atomic radii, there are another different types of radii present. So we can write like atomic radii. There are another different type of radii, and such are number 1 is your covalent radii, number 2 is your metallic radii, next is your Van der Waals radii. At first I will discuss about the covalent radii. What is covalent radii? Suppose take a molecule, take a diatomic molecules. That means there are 2 atoms present and they are bonded to each other by covalent bond. Suppose this is your one atom and this is your another atom. The atom having the nucleus here and this atom having the nucleus here. This is the center of the atom, this is the center of this atom. And this indicates that overlapping of 2 orbital, and that is your considered the covalent bond. This is the distance between the 2 center of the 2 nuclei of the 2 atom. This is the distance. Suppose I want to take, this is your DC, distance between 2 covalent bonded atom of 2 atom in a covalent bond. This is your distance. Then what will be the half of this distance? This is the half of DC. So it is considered as the RC and it is also considered as the RC. What is RC? That is your called covalent radii. This distance is considered as the covalent radii. Then what will be the statement for covalent radii? Covalent radii. What will be the statement for covalent radii? Covalent radii is defined as the half of the distance between the two covalent bonded atom. Distance between the two center of two nuclei of two covalent bonded atom. These two covalent bonded atom, and these two center. Covalent radii is defined as the half of the distance between the two center of two nuclei of the two covalent bonded atom in a covalent bond. This is called covalent radii. This is the diagrammatical representation for covalent radii. Then we can write mathematically also the covalent radii. Mathematically, the covalent radii, that is you suppose taken as RC, equal to distance between two center of the two nuclei of two covalent bonded atom divided by 2. That is the half of distance between two center of the two nuclei of two covalent bonded atom. That is called your bond length. That is called your bond length. That is suppose taken as DC. So we can write covalent radii RC is equal to bond length divided by 2. This is your mathematical representation for covalent radii. If the distance between two hydrogen atom in a H2 molecule is 74 pm, then what will be the covalent radii for the molecule? Then we can write the covalent radii of then the covalent radii RC is equal to 74 by 2 equal to 37, that is your 37 pm. Next I will discuss about the metallic radii. Second is your what? Metallic radii. Suppose take a metal crystal. In metal crystal there are large number of metal atoms are present. Suppose take two metal atoms. This is your two metal atom. Remember, these two atoms do not form the covalent bond. They are just touching to each other. This is your center of one metal atom. This is the center of another metal atom. This is the distance. Suppose it is taken as dm. Dm means distance between two center of the two nuclei of two adjacent metal atom. Then what will be the half? Half means this. This is your said to be Rm and this is also Rm. Rm means metallic radii. Then what will be the definition for metallic radii? The metallic radii is defined as the half of the intramolecular distance between the two center of two nuclei of two adjacent metal atom. This is the metallic radii. This is your diagrammatical representation for metallic radii. Next we can give the mathematical representation. Mathematically metallic radii suppose taken as Rm equal to distance between two nuclei or distance between two center of nuclei of the two adjacent metal atom in a metal crystal. You can also write in a metal crystal divided by 2. Simply you can also write distance between two nuclei of two adjacent metal atom. Simply you can write. Suppose this is taken as Dn. Then what will be the formula? Rm is equal to dm by 2. Suppose take an example. The distance between two potassium atom in potassium solid is 4.62 angstrom. Then what is the metallic radii? Then the metallic radii equal to 4.62 divided by 2. That is your 2.31 angstrom. Next I will discuss about the van der Waals radii. Third is your van der Waals radii. Van der Waals radii. Take two molecules and the two molecules are diatomic. This is your one molecule made by two atoms. This is the center, this is another center. Take another molecule. This is the center, this is the another center. This is your one molecule made by two atoms. This is the another molecule made by another two atoms. This is the distance. Suppose take this distance is a dV. This is your said to be dV. Then what is the half of dV? This is the half of dV. Suppose this is your RV. This is your said to be also RV. Half means equal. RV is equal to this RV is equal to this RV. This is your said to be van der Waals radii. Then what will be the statement for this reaction? Before going to this statement, this atom and this atom are non-bonded to each other. This atom and this atom are bonded to each other. This atom and this atom are bonded to each other. But remember, this atom and this atom are non-bonded to each other. This atom and this atom are non-bonded to each other. This atom and this atom are non-bonded to each other. Tell me, select two atoms which are non-bonded to each other and neighboring to each other. This atom and this atom are called non-bonded neighboring atom. We cannot say this atom and this atom are non-bonded neighboring atom. No, this is not. No doubt, it is your non-bonded, but this is not your neighboring atom. This atom and this atom are called non-bonded neighboring atom. And this is your nucleus. There are two nucleus present here. Then this distance, the half of this distance is called your van der Waals rating. Then what will be the statement? The van der Waals rating is defined as the distance between two center of two nuclei of two non-bonded neighboring atoms in two adjacent molecule in a solid. This is the definition of van der Waals rating. Then what will be the mathematical representation? Mathematically, we can write van der Waals rating, that is your R V equal to distance between the two center of two nuclei of two non-bonded neighboring atom in two adjacent molecule. That is your taken as dV divided by 2. So we can write Rb is equal to dV by 2. This is your van der Waals rating. Suppose take an example. The distance between two adjacent chlorine atoms of two neighboring chlorine molecule is 360 pm. Then what is the van der Waals rating? Then van der Waals rating, that is your Rb, consider as Rb is equal to 360 by 2 is equal to 180 pm. From the above three discussion, that is your covalent rating, metal rating, van der Waals rating, we can conclude that this is the representation for covalent rating. This is the covalent rating. This is the representation for metallic rating. This is your Dm. Half means this. This is your Rm. This is Rm. This is your said to be ready, that is your dV, and this is your said to be RB. This is your said to be RB. From this discussion, it is clear that RB greater than Rm greater than Rc. That means van der Waals radii greater than metallic radii greater than covalent radii. Look at that, there is a large distance. This is closer slightly as compared to this. This is a more closer. There is a overlap. So we can think that this is the shortest distance as compared to this distance as compared to this distance. So the half is obviously smaller than this half, and obviously this half smaller than this half. That means we can think that covalent radii is smaller than metallic radii, smaller than van der Waals radii. Suppose I want to compare the atomic radii of the elements present in the periodic tables. Look at that. This is your modern periodic table. This is your group 1 element, group 2 element. These are the group 3 element, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 13, 14, 15, 16, 17. This is your 18. 7 periods are there. Period number 1, period number 2, period number 3, period number 4, period number 5, period number 6. This is your period number 7. Suppose I want to compare the atomic radii of the elements along the periods. Suppose I want to take the sodium atom. This is your sodium atom. It having electronic configuration, that is your K cell having 2, L cell having 8, M cell having 1. This is the sodium. Suppose I want to take magnesium. Magnesium having atomic number 12, but sodium having atomic number 11, magnesium having atomic number 12. Suppose I want to draw the electronic configuration. K cell having 2, L cell having 8, M cell having 2. Next I will draw the electronic configuration of aluminium. Atomic number of aluminium is 13. K cell having 2 electron, L cell having 8 electron, N cell having 3 electrons. If I want to draw the electron configuration of silicon, then the N cell gradually filled up. There is no increase of the cell. There is no increase of the cell. At first, in case of sodium, the first electron entered into the M cell. In case of magnesium, the second electron entered to the M cell. Here the M cell remain constant. That means valency cell remain constant. But there is an increase in the number of electron. If there is an increase in the number of electron, that means there is an increase in the number of proton. If there is an increase in the number of proton, there is an increase in the nuclear charge. Always remember, the nucleus always attract the electron towards itself. Again, we know that the distance between the valency electron and the nucleus is called atomic radii. If the nuclear force goes on increases, then the valency cell is more attracted by the nucleus and it comes into closure towards the nucleus. In case of sodium, there are 11 protons are present. In case of magnesium, 12 protons are present. In case of aluminium, 13 protons are present. Here the nuclear charge is maximum. As a result, aluminium nucleus attract the electron present in the M cell more as compared to magnesium and sodium. As a result, the M cell more closer to the nucleus in case of aluminium as compared to magnesium as compared to sodium. If I want to know about the silicon, phosphorus, sulfur, chlorine, argon. From aluminium to silicon, next phosphor, next sulfur, next chlorine and argon, what will happen? The nuclear charge, nuclear force goes on increases as a result. The M cell come closer and closer as compared to another. That means the M cell of aluminium is less closer than M cell of silicon, less closer than M cell of phosphorus, less closer than sulfur, less closer than chlorine. That means the distance between the nucleus and the valency cell goes on decreases from sodium to magnesium, next aluminium, next silicon, next phosphorus like this. As a result, the atomic radii goes on decreases because it is the distance between the nucleus and the valency cell. If the number of electron goes on increases, then number of proton obviously goes on increases for an atom. If number of proton goes on increases, then the nuclear charge, nuclear force goes on increases. If nuclear force goes on increases, then it attract more towards itself to the valency cell. As a result, the atomic radii goes on decreases. From left to right, the atomic number increases. As a result, the nuclear charge or nuclear force goes on increases. As a result, valency cell come closer and closer towards the nucleus. That's why from left to right, the atomic radii goes on decreases generally. That means we can write a point. The atomic radii goes on decreases from left to up to inert gas because there is a regular increase of nuclear force while the valency electron present in the same cell, but there is a sudden increase in atomic radii at inert gas because inert gas have van der Waals radii. They cannot form covalent bond. If the inert gas, this means helium, neon, argon, krypton, xenon, radon. If the inert gas can form covalent bond, then it have covalent radii. But it only able to form the van der Waals radii. We know that van der Waals radii greater than metallic radii greater than covalent radii. Suppose I will think about the atomic radii of second period element. Then what is the order? Lithium having more atomic radii than beryllium. Next, more atomic radii boron, carbon, nitrogen. Next is your oxygen. Next is your chlorine. Up to inert gas. Then there is sudden increase of the atomic radii at inert gas. That is your neon. That means chlorine, do not have more atomic radii as compared to neon, but neon having more atomic radii as compared to fluorine. This is because neon shows van der Waals radii, fluorine, oxygen, nitrogen, carbon, boron, beryllium, lithium shows covalent radii. We know that van der Waals radii is more than covalent radii. That means say this is your covalent radii, this is your van der Waals radii. Van der Waals radii is more than covalent radii. Due to the increase of the nuclear force, the atomic radii goes on decreases because the nuclear charge, more nuclear charge attract the valence shell towards more. As a result, atomic radii goes on decreases up to inert gas. But at inert gas there is a sudden increase of atomic radii. This is due to the van der Waals radii of the inert gas, because covalent radii does not shown by inert gas. So from the discussion it is clear that atomic radii goes on decreases from left to up to inert gas. Left to up to inert gas means group number 1 to group number 17 decreases then increases.
Suppose I want to compare the atomic radii of the element present in a group.
Suppose think about hydrogen. Hydrogen having atomic number 1. Hydrogen having K cell. That is your 1. Next we think about lithium. Lithium having atomic number 3. That means K cell having 2. Your L cell 1. This is your KL. Next I will think about the sodium. Sodium having atomic number 11. K cell 2, L cell 8, M cell 1. Look at that. This is your supposed nucleus. This is the valence shell. This is the distance. This is your active atomic radii for hydrogen. This is your supposed nucleus. This is the distance which is considered as atomic radii for lithium. This is suppose your nucleus. This is the distance which is considered as atomic radii for sodium. What happens? The atomic radii goes on increases. Why? Due to addition of new cell. In hydrogen there is only one cell. In lithium there are two cells. One is your K cell, another is your L cell. But in sodium there are three cells present, K, L, M. As a result, the distance goes on increases because the valence shell goes on increases from the nucleus. Similarly, if you think about potassium, another new cell will be added. That is your M cell. That is your fourth number cell. In rubidium, fifth number cell will be added extra. In cesium, sixth number cell will be added as an extra cell. Francium, seventh number cell will be added as an extra cell. That means the number of cell goes on increases from top to bottom. As a result, the atomic radii goes on increases from top to bottom. So we can write the atomic radii goes on increases from top to bottom due to addition of new cell. So take an example. Atomic radii of helium smaller than atomic radii of lithium, smaller than atomic radii of sodium, smaller than atomic radii of potassium, smaller than atomic radii of rubidium, smaller than cesium, smaller than francium. This is the order of atomic radii in the increasing order. This is your said to be increasing order. That is all about your atomic radii.